Okay, conjecture number 74, the tangent conjecture. The tangent to a circle is perpendicular to the radius drawn to the point of tangency. So what we're showing here is a radius drawn to the point of tangency, and we have tangent line BC to circle A. If I were to measure this angle would be a 90-degree angle. So no matter how this is moved, that will always stay 90 degrees. Conjecture number 75. The tangent segments conjecture. Tangent segments to a circle from a point outside the circle are congruent. So if I were to measure segments AD and CD, you can see that those two lengths will be congruent. So as this point moves, let's see if I can move that point. As that point moves, you can see that those segments still stay congruent, and we can mark those as being congruent as well. Conjecture number 76. If two chords in a circle are congruent, then they determine two central angles that are congruent. So if these two segments here are congruent, as I've shown, you're going to find that these two central angles are also equal. As that moves around, that will maintain congruency. Conjecture number 77. If two chords in a circle are congruent, then their intercepted arcs are also congruent. So again, I have congruent chords, and I also have congruent arcs. Conjecture 78. The perpendicular from the center of a circle to a chord is the perpendicular bisector of a chord. So if I'm going from the center perpendicular to the chord, then segments AB and BC are going to be congruent. Conjecture number 79. Two congruent chords in a circle are equally distant from the center of the circle. So what I have here is I have two chords that are congruent. And if I were to measure the distance back to the center, the distance are congruent. So the segments to the center of the circle are the same. And we can even mark here that these are right angles to show that you always measure on the perpendicular. Conjecture number 80. The perpendicular bisector of a chord passes through the center of a circle. So the same idea here, that if these are at 90 degrees, and these segments are bisected, they will always go back through the center of the circle. Conjecture number 81. The inscribed angle conjecture. The measure of an inscribed angle in a circle is half the measure of the arc it intercepts. So if I was to measure this angle, and then measure the arc, and I take I take the measure of the arc and I divide it by the measure of the angle, it will always be in a ratio of 2 to 1. The measure of the inscribed angle is always half that of the intercepted arc. Conjecture 82. Inscribed angles that intercept the same arc are congruent. So here what we're showing is we have two angles. These two angles are both intercepting the same arc. If I was to measure this arc, and I was to measure these angles, these angles will always be congruent. So no matter where they sit on the circle, if they intercept the same arc, those two angle measures will be the same. Conjecture number 83. Angles inscribed in a semicircle are right angles. So if this intercepts half a circle, then this angle measure will always be 90 degrees, no matter where it sits. Conjecture 84. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So here I have marked the opposite angles of a quadrilateral inscribed in a circle. If I measure those angles and then calculate, if I find the sum of those two angles, the sum will always add up to 180. So no matter how this moves around. Conjecture 85. Parallel lines intercept congruent arcs on a circle. So if I measure the slopes to show that these are parallel lines, and then I measure the arcs, you can see that as long as the lines are parallel, the intercepted arcs will always be congruent. 86. The circumference conjecture. If C is equal to circumference and D is equal to diameter, then there is a number pi such that circumference is equal to diameter times pi. Because diameter is equal to 2r, where r is equal to the radius, then circumference is equal to 2 pi r. So what are we showing here? If you measure the distance around the circle, if you measure the circumference, and you measure the distance across the circle, measure the length, and I calculate the distance around the circle divided by the distance across the circle, we will always get this magical number pi.